Hello everyone. Today we are going to discuss about databases and the database basics. What are databases? What are transactions? What are asset properties and stuff? Right. So before that, I'm going to explain you about some repo. This repo name is technical basic coverage. So in this thing, we are going to cover all the technical basics such as Node.js, networking, DBs, frontend, Python backend, queues, etc. And unifolders will also come up based on the requirement. And these are the instructions if you want to contribute or you want to learn and you want to uh, revise your basics, etc. So these are the rules or these are the conditions you can follow through and can learn the stuff. So today we are going to start the section DBS in it, which is databases, and everything here is divided into phases. And in this roadmap, already Node.js, JS, and TypeScript is completed. So now we are coming to the DBs, right? So today we are going to look at the phase one, which is this thing, fundamentation of databases. So we are going to learn what is a database, what is a transaction, what is ACID, and yeah, and we are going to demo a small mini transaction simulation using the SQL or Postgres SQL, right? So now let us get into it, right? So coming to the database, right? A database means some place where we can store our data organized in a collection wise or in some format such that it will be structured and can be accessed, written, read, edited, deleted seamlessly. So there are two different types in this database. So DB, right? One is structured and unstructured. So in this data, there will be structured and there will be unstructured data. For us, let us say you have a user data, such as I am a user, so my name is Kianvardhan, I have a student ID, my roll number, which is it, and I am belonging to a section, and I am from a branch called CSC, etc., which are just key names, and these are unique and there will be structure. And let us say there is an video or there is an audio which will be divided into byte streams, or else there is a data which you don't know it will be like this and you want to have some leverageability. So that is called unstructured data, right? And the one which I have explained is called structured data. Now coming to this, uh, how the structured data will be stored. So there are databases which provide us a structured format such as MySQL, PostgreSQL. These are one of the examples. There are so many databases. So these are relational database. What is meant by relation? Relation means a table, right? So we can store rows and columns in table. So I will show you an example such that what do you meant by relation DB. So this is a PostgreSQL table and there is a data in this. What is the data here? ID, email, name, password, salary. And these are the columns and we have rows. So a single row will be unique and the rows will be defining the data. So right here we can see the username is different here, Gyana, and here the username is different here, Gyana Vardhan. So this is unique here, and they have IDs, emails, passwords, and they have salary. So everything which we want to define is divided into columns, and every single row will be a single uh, right a row. Right, for example, let us say that you have two users, so you have two rows, right? So similarly, the rows are stored in this way, and this is how a relational database will be, right? Now coming to the non-relational database, right, which is unstructured data. So we can store as we like in this database, right? And the example for these are NoSQL DBs, which the first choice is and the most popular choice is MongoDB, right? And the next one is there will be so many examples like Redis, So this will be just a key value pair, a database, and MongoDB is document database. So let us see the example of the MongoDB too. Right, this is a MongoDB database, and I have been storing so many things in it. And let us just see one of the things. As we can see, this collection name is courses, and here we are storing documents. So this comes under the document, right? It has also key value pairs, right? The ID is a key and it has a value, name is a key and it has a value, and this whole thing comes under a document. So there are different documents. As we have rows in SQL, we have documents in this MongoDB. So this can store so much unstructured data. For example, in SQL you can say that we have to store a row inside a row. That will be most complex thing. But you want to store arrays and JSON things are objects inside another key. So it is possible here. As we can see here, we have a syllabus thing and we have array in it and we have objects in it. So that object is, again, it is having key value pairs, which is weak topic content. Again, weak topic content. So this is an example of a unstructured DB, which is a NoSQL and also known as document DB, which is MongoDB, right? Now, as we have got the introduction of the DBs, let us get into the next thing, which is a transaction, right? So, what is a transaction? Right? These transaction mostly are very important in the SQL DBs, but will be also present in other DBs, right? So, coming to the transaction, let us say we have a sequence of operations in the DB. One is uh, updating a user, right? Um, Again, updating second user, right? Now in these things, if something fails and this affects the other users and stuff, so we can't go back, right? So in these scenarios, we assume something might fail or something might go wrong and something should be done well. Then we come under transactions. A transaction can be started in SQL using begin and ended using commit, right? So before this updating the first user and before updating the second user, we'll put a comment called begin, and at the end of the thing we'll put a comment called commit. So if anything happens wrong between these two things, it will stop right there and will revert all these things which are done between this, and will be starting at the same state which we are initially there, right? So why is this done, right? Let us take one of the example, right? We have a users table and the users have ID, salary, name, right? And there are two users, okay? And those two users are Ellis, Bob. Ellis has 6,000 salary and Bob has 3,000 salary, right? Now Ellis wants to transact some 2,000 money to the Bob, right? Alice to Bob, 2,000 money transfer, right? So that is the main objective here. So in this process, if in that process of transaction of 2,000 rupees, if something a network issue or a user has clicked back button, the transaction might fail at some process, right? So if at this time, if the detection is gone from Alice and Bob didn't get the 2000 as the user clicked back, and the user 2000 money is been again not sent to the Alice. So in these situations, the transaction is not done well, the money transfer is not done well, so the users will be affected. So when the transaction is initiated, right? When the transaction is initiated, now Alice transfers 2000, right? And it is debited from the Alice account. But network issue happened. So it will stop the transaction, it will stop the next SQL command or the next SQL query there, and will again put the 2000 back into the Alice account. So Alice salary will not be disturbed, and Bob's salary will not be disturbed, right? So in this situation, we can again do the transaction and it will be done safely, right? And this is the purpose of transaction. So while doing transactions, the transaction is meant to follow something called acid, right? And this is the next concept we are going to discuss. In acid is a acronym for atomicity, consistency, isolation, and at last durability, right? So now we are going to discuss this one by one, right? Why are these important and what are these atomicity, durability, isolation, and consistency, right? The atomicity, let us see the definition of atomicity. Ensures that a transaction is all or nothing. If any part of the transaction fails, the entire transaction is rolled back, which means that, which we have discussed earlier, if everything for a transaction goes well, everything goes well and everything is completed, cool. But if anything goes wrong, the entire transaction is reverted. Got it? Right. So as we have seen the example earlier, if 2000 has been failed because of the network issue, again the 2000 will be coming back to the Alice account, right? Now coming to the consistency. A transaction must bring the database from one valid state to another, maintaining all the predefined rules, right? For example, let us say um, before one situation, the state is like this and the state is like this. So in this state, we are allowing balance negative 2000, but we won't want that. So after this state, we have set a constraint that only balance should be greater than or equal to 0, such that after this, if any amount is added and if negative amount is added, the DB will say that no, the negative amount is not allowed and only the positive amount is allowed, which is 0 to any infinity positive value, right? So which means that we will maintain the consistency across the DB. So these business rules will be applied for the data too. For example, a bank account is there and the bank account could not have the negative balance, right? So this can be applied here and consistency can be maintained. Got it? Right. Now coming to the next thing, which is isolation. Right, the isolation is that, so if there are two transactions happening relating to a single account or double accounts, right? So the one transaction does not disturb the second transaction. So let us say there is book my show and you want to book a seat and there is a single seat available, right? Now a user 1 is there and a user 2 is there, and they're both trying to book the same thing. So they have selected the seat, finalized the cost, and started the transaction. So either one of the transaction will be started and the other one will not be started. Say, right, for example, this seat is open for 3 minutes and this guy has started doing the phone pay or something transaction. So when he has started, he cannot select this seat. The user 2 cannot select this seat because he has already started the transaction for this. And in case if this fails, only the second user will be again able to select the seat, or else the transaction will be completed, the seat will be filled, and he cannot disturb the seat now. So this seat will be isolated from other things. So if a transaction is happening, any other member or any other user can't undo the transaction or middle with the transaction, right? This is called isolation. Now coming to the durability. Once a transaction is committed, it is permanent even if the system crashes afterwards. So let us say this seat is booked, right, by a person called user 1. Now let us say there are so many users for the book my show and the system and the db is crashed. So before crashing or something goes wrong, the transaction ensures that this is written into the db and is committed well, such that even though something goes wrong, that will be written in the hardware and nothing can change that. So the durability, how much is it standard, how much can we believe it? So these are the asset properties which are included in the transactions and SQL DBs and relational DBs, such that the data will be secure and best for our usages. Got it? Right. Now let us get into the demo. Right. What is the next thing here? Yeah. So yeah, let us list the examples first. So banking systems where we will do transactions, transfers, deposits, withdrawal are one of the best examples for the asset properties. Like flight and train bookings, where as I have mentioned that one seat will be booked at a time and everything will be waiting. So any blockage things will not go wrong, right? Now again, healthcare and stock tradings, anything which includes very sensitive details and transactions, or uh, so many people will be trying to do for a same thing, like e-commerce booking. Let us say there is an Amazon big billion day, so everybody will be trying for a single item, putting order, and the number of stocks available and everything related to this will be following the asset properties, such that nothing will go wrong and users will not get uh, defied for the issues of ourselves, right? So these are the examples which can be used in the acid things, right? Now let us, I have spinned up a Docker container of the Postgres DB such that we can simulate a small level transaction, right? So yeah, so for the transaction we need a relation which is a table. So let us create a table. I have created this practice.md such that everyone can create the table and simulate the transaction, right? So this is the SQL, right? So in this SQL, we have a query called create table accounts. So this is the syntax for the SQL, and this is the name of the table. Okay. Now ID is serial, so it will automatically increase, and name varchar. Varchar is a data type of which is similar to string, which will store characters, and name is not only here. So if anybody want to create a user or account for a user, so then the name should be not null, and the balance is decimal. Decimal means again a data type for the number storage. So there is a check for this balance, which is balance greater than or equal to 0. So we cannot create a balance of minus 2000 or minus 1 such that the balance will not be negative, right? So the table is created. To list the DBs, the command in the Postgres is -dt, right? So as we can see, we have a table here, accounts, the table is created. So the next thing, we want to see if there is any data in the table. Select star. Star means everything from accounts, and as we know, every SQL command should end with a semicolon. As we can see, there are 0 rows and there are 3 columns, which is id, name, balance, which you have created earlier, right? So now we will append data into it. Insert into accounts, name, balance. So we are defining that what are the values we are giving, name and balance, right? And values, Alice 5,000, Bob 3,000. So there is a output insert 0 comma 2. So 2 rows are inserted. So let us clear the console and again select star from accounts. Right, as we can see, ID is given as we are using the serial, and the name is Alice and Bob, and the 5,000 30,000 amount is done. Let us try to insert the accounts another value. Okay, name, again same format, balance, values, Charlie, and let us try with a negative value, -20. As we can see, we got an error. Oh, sorry, 1 minute, I have typed the spelling mistake wrong. Accounts, as we can see, we got an error. New row for relation accounts violate check consent account balance check contains 3 comma Charlie comma -20. As we can see, we have given balance greater than or equal to 0. So again, control L, select star from accounts, and there is no Charlie enrolled. Okay, so this is how the constraints work. So let us get to the next thing, transaction. So how, as we discussed, we will begin a transaction using the begin command and end a transaction using the commit command, right? So let us do this. What we are doing is, the hyphen is the format for the commenting. Update accounts, set balance equal to balance -1,000, where name equal to Alice. So we are deducting 1,000 from the Alice, and update account, set balance plus 1,000, where name is equal to Bob. So at a high level, we are transferring 1,000 from Alice bank account to Bob bank account. So let us execute this. The transaction has begin update one. So we have updated one row and again updated another row for the Bob, and we have committed. So again, control L, select star from accounts. As we can see, uh, the Alice and Bob have 4,000 and 4,000, which is 5,000 is deducted 1,000 and it is added to the 3,000, which is 4,000 now. Got it? And the transaction is done very good, and there is no problem in it. So now let us simulate a transaction which has a fault, right? So here we are doing balance -6,000, which will mention that the balance will be negative. So let us do this. As we can see, it is giving an error. We are doing -6,000 for Bob account, and it is saying that it is giving -1,000. We can't do that. And here we have a new comment which is not mentioned here, which is rollback. So what does a rollback do? So if anything goes wrong, we should go back to the state of the initial thing, which is the task done by the rollback. We are rollbacking our status from this state to our initial state, which is before this transaction. Got it? Now again, let us do select star from accounts. As we can see, there is no change in the accounts. So now let us drop database accounts. Okay, I think something wrong happened. We have the, okay, let us see the cheat sheet for the dropping of the database. Drop table. Okay, I have done the command wrong. Drop table accounts. As we can see, the table is dropped, and again we do my dd, and let us say select star from accounts, and there is no accounts table. So right guys, this is how we simulated a transaction, and this is how the asset properties work in a relational DB, right? So yeah, I will be commenting the entire details of the database, the transaction thing which we have explained, and what are the things I have done to set up a Postgres DB. And reminder guys, this should require Docker thing, right? And I will commit these things into the branch, and we will get a PR to merge in the main branch. So you can also see the details and can learn from it and use this repo. Got it? Thank you, guys.